numericals on self-induction. Question number 1. What is the self-inductance of a coil in which magnetic flux of 50 milliweber is produced when 2 ampere current flows through it? So let's write the solution. We are given phi equal to 40 milliweber. Milli means 10 power minus 3 Weber. Current is given as 2 ampere. Now, if you remember, I told you phi proportional to I or phi equal to Li, where L is self-inductance. So here we apply the same formula, phi equal to Li. Our purpose is to get L, so phi upon I. We put the values 40 into 10 to the power minus 3 divided by 2, which will be equal to 20 into 10 to the power minus 3 or 2.0 into 10 to the power minus 3 Henry. Let's see next question. An inductor having inductance of 5 Henry carries a steady current of 2 ampere. How can a 50 volt self-induced EMF be made to appear in the inductor? So it is only possible when current is changed. So let's write the formula. Here we are given L equal to 5 Henry. EMF is given as 50 volt. I is given as 2 ampere. We know that phi equal to Li and E equal to minus d phi by dt, which will give minus L di by dt. So we can put the values 50 here. We are writing this formula. E equal to minus L di by dt. So here 50 equals L is 5 Henry. Di means I2 minus I1. Suppose current becomes 0 and initial current is 2 ampere divided by time. That is to be found. So from here we get 50t equals 10 or t equal to 10 by 50 or 0.2 second. Thus, an induced EMF of 50 volt can be generated by reducing the current to 0 in 0.2 second. Let's see next question. What is the self-inductance of an air-cooled solenoid 50 cm long and 2 cm radius if it has 500 turns? So length of solenoid is given as 50 cm, which is equal to 0.5 meter. The radius is given as 2 cm, which is equal to 2 into 10 to the power minus 2 meter. So from here we can find the area of the turn pi r square, that is 22 by 7 into 2 squared 4, 10 power minus 4 meters square. Now we are given number of turns n equal to 500, and we know that mu 0 is 4 pi into 10 to the power minus 7 Tesla meter per ampere. Now, if we are given a coil and it has number of turns capital N and the current I flows through it and area of turn is capital A, in that case, self-inductance is given by mu naught N square A divided by L. So here, same situation is there. So we apply the formula L equal to mu naught N square A divided by L. We put the values. So 4 pi into 10 to the power minus 7 times N square means 500 square times area. Area is pi r square. So 22 by 7 into 4 into 10 to the power minus 4 divided by length. Here length is given 50 centimeter. It means 0.5. Now we can evaluate it. So it will come out to be 7.89 into 10 to the power minus 4 energy. Now let's see next question. Next question is an air-cooled solenoid is of length 30 centimeter, area of cross section 25 square centimeter, and number of turns 500. Carries a current of 2.5 ampere. The current is suddenly switched off in a time of 1 millisecond. How much is the average back EMF induced across the ends of the open switch? So switch in the circuit. So let's write the information given. So length of solenoid is 30 centimeter means 0.3 meter. Area is given as 25 centimeter square, that is 10 to the power minus 4 meter square. Number of turns is 500 and time, let's write it as dt, is 1 millisecond means 10 power minus 3 second. And the change in current is di. So final current is 0, initial current is 2.5, that is minus 2.5 ampere. With these informations, let's write the formula and evaluate. So phi equal to Li and E equal to minus d phi by dt, from where we get minus L di by dt. So we write it here. So E will be equal to minus L di by dt. We put the values. So E equals minus L. Here our purpose is to get back EMF, and if we are given a long solenoid and we have to find out L of the solenoid, so that is given by mu naught N square A divided by L. So we have to write that formula here. So minus L mu naught N square A divided by L multiplied by di by dt. Now let's put values. So E equal to minus mu naught is 4 pi into 10 to the power minus 7 into number of turns squared, that is 500 square, times area is 25 into 10 to the power minus 4 into di by dt. Di is given as minus 2.5. dt is given as 10 power minus 3 divided by mu naught n square times a, that is 2. This is 25 into 10 power minus 4 into di is minus 2.5 divided by dt is 10 power minus 3 divided by L, and the length of solenoid is 0.5. Now we can simplify. So it will be equal to this minus, and this minus will become plus. So we can write 4 into 3.14 into 500 squared into 25 into 10 power minus 4 into 2.5, and this 5 can be written as 5 into 10 power minus 1. 0.5 is 5 into 10 power minus 1, and this minus 3. So in denominator, it will become 10 power minus 4. So we can write it as 10 power 4 in numerator, and in denominator, only 5 is left. Now, if we further simplify, so 10 power 4, 10 power minus 4 will cancel out. And if we multiply, so 5, this blue 5 5s are, and this 5 into 2.5 will become 12.5 multiplied by 4. This will become 12.56 into this 5 is left. No, this 5 is multiplied already. That gives 12.5. So only this 500 square is left. So here we have missed one thing. If you go back to what we left, here is this value bars. This is 4 pi into 10 to the power minus 7 term is missing, because L was mu naught into 4 mu naught into n square a upon L. So here value of mu naught is 4 pi into 10 to the power minus 7. So minus 7 was missing. So here we have to write it as minus 7. And then we simplify it. So it will come out to be 6.542. That's the answer. Thank you for watching.